Well, hello everyone, and welcome back to Maths. Last time we learned how to flip the number line by applying negatives to it, and we saw that it had some cool examples regarding mirrors. So today we're going to be practicing those concepts with these questions I've prepared. Go ahead, pause the video, try them out yourself first, and without further ado, let's get into them. Alright, so number one says, calculate the following by flipping the number line. So we have multiple negatives on each of these, and every negative corresponds to a number line flipping. So we can calculate those by flipping a number line. So if we take a number line like this, and if we take one like this, then we can get ready to go. But before we get going here, I would just like to mention how I actually made this in case any of you wanted to make one for yourself. So the way it works is you take a number line and label it as normal. And then you do the same thing, except you do it backwards, where 0 is still in the middle, and all your negatives are on the right, and all your positives are on the left. And by doing this, you can basically get the flipped version of the number line. And then simply tape or glue it to the back of the other one, and then you should be able to flip it, and you're good to go. So part A, we have negative, negative, negative 5. So we have 5 here, and we're applying 3 negatives to it, so we're going to be flipping the number line 3 times. 1, 2, 3. And we see that 5 lines up with negative 5. So negative, negative 5 has to be negative 5. Alright, and then part B, we have negative, negative 2. So that's 2 negatives, which means 2 flips. So put the number line back how it was started, and we'll flip it twice, keeping 0 centered. 1, 2 flips. And that takes us back to where we started, right? With 2 lining up with 2. So we get that negative, negative 2, or 2 flips on the 2 gives us 2. And lastly, we have all these negatives with the 0. I don't even know how many negatives there are, to be honest. I just kind of spammed the minus button. So that kind of gives us a sign that maybe we don't actually need to know how many negatives there are. So we can flip this number line a bunch, but 0 is always in the middle, right? 0 is the fixed point. That's what we're rotating it around. So if that's the case, it doesn't matter how many times we flip this, 0 is always going to line up with 0. So the answer for part C is just going to be 0. Alright, hope that made sense. Now if you recall, there was another way that we could determine what these negatives simplify to by just looking at the number of negatives there are, and we discussed that in the last video. So for part A, we have negative, negative 4. So this one, we have 2 negatives, right? And is 2 an odd or an even number? Well, 2 is even, right? And since 2 is even, that means this should just simplify to positive 4. Since an even number of flips will always take us back to where we started. So if we're taking us back to where we started, then this 4 flipped twice will be just 4 again. Alright, and part B, we have negative, 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 negative 6. Alright, in this case, we have 4 negatives, which is also an even number, right? So that means this has to equal 6, because we get back to where we started with an even number of flips. And lastly, part C, we have 1, 2, 3, 4, 5, 6, 7 negatives here. And so that's an odd number of negatives, right? 7 is an odd number. Alright, so that means an odd number of flips means we're ending up on the opposite side from where we started. And if we started with 8, the opposite side of 8 is negative 8. So an odd number of negatives will result in a negative number, so we get negative 8 as the result. Alright, let's move on to part 3. Alright, 2 mirrors are placed in front of each other such that you can see infinite copies of the mirror inside of each one. So if you recall, we talked about this last time, where you have 2 mirrors in front of each other, you kind of get this infinite mirror glitch where this mirror sees a copy of this mirror, which sees a copy of this mirror, which sees a copy of this mirror, right? And it just keeps on going like that over and over again, and so you get infinite copies of the mirror inside of each other. And the question says, you hold up a number line and focus on one of the copies of the mirror and see that the number line is straight forward and not backwards. So we take a number line here, right? Let's say we're holding up the number line so it's facing this mirror here. And so inside this mirror, there's going to be an image of the number line. That's going to get reflected and produce an image in this one. and that'll get reflected and produce an image in this one, and then in this one, and it's going to just go back and forth like this, right? And so in every single one of the images of the mirror, it's going to contain a copy of the number line. Now, if we look in this mirror, this is the first mirror that sees the number line, and mirrors always reflect things. It flips them, right? So we can think of this as like applying a negative to the number line. But then this mirror is going to see this image here, and it's going to flip that. So that's like applying another negative. But applying two negatives, that's an even number of negatives. So in this mirror here, we're going to see a straight version of the number line, whereas in this one over here, we're going to be seeing a flipped version. And we can continue. So with this straight one, this mirror is going to reflect that and produce another flipped version of it, right? So this is like applying our third negative. 3 negatives, that's an odd number of negatives, so it'll be a flipped version or a negative version of what we had before. So this is going to be flipped still. That reflects over here. That's applying another negative. That's like our fourth negative. And that is going to be straight. We can read that with the negatives on the left, positives on the right. Over here, it's going to be flipped again and back and forth. So all the images of the number line here are basically odd images, right? 1, 3, 5, 7, and so on. And all the images in here are our even images, 2, 4, 6, 8, and so on. So every number line that we see in these mirrors, in every image of the mirror, will be flipped. And every number line we see in these mirrors will not be flipped. They're going to be straight. We can read them just like we would normally read the number line. So it says that we hold up a number line and focus on one of the copies of the mirror and see that the number line is straight forward and not backwards. What can we say about the copy of the mirror we're looking at? Well, we're focusing on one of the copies of the mirror, but we said it's straight, so that means it has to be inside of this mirror here behind the number line, not where the number line is facing. So any of these copies will have the number line straight because they correspond to an even flipping of the number line, which takes us back to the image that we had in the first place. All right, I hope that makes sense, and I hope you found that interesting. I think this mirror reflection stuff is really cool to think about. All right, so for part 4, we see that I flipped the number line and then divided it by 2. Will this produce the same outcome as if I divided the number line by 2 first and then flipped it? So this is saying we're doing two things to the number line, and it's wondering if the order in which we do it matters. So we take a number line here, and because we're going to be dividing it by 2, I made it so that every number is 2 ticks apart so that we can compress it easily. It says we flipped it and then divided it. So let's flip it first. So we take a number line here, right? And then we're going to flip it. Okay, so that's applying a negative to the number line. And then we are going to divide it by 2. That's going to look something like this. So dividing it by 2, it compresses the number line down, makes the distances to be 2 times smaller, and that will line up exactly as such, right? So 0 is fixed, -1 is here now, because the distance before was 2 ticks long, and now it's just 1 tick. So it's exactly 2 times compressed from what it was before. We've essentially divided this number line by 2, right? And we see that the negatives are on the right side, the positives are on the left. We haven't changed the direction at all, right? Okay, so that is the first case. Now the second one, we're taking the number line again. And this time we're dividing it by 2 first. So dividing it by 2 will produce something like this, where we've compressed it down. The distances between numbers are now 2 times smaller than they were before. And we can check some numbers to make sure. 8 corresponds with 4, since 8 divided by 2 is 4. 2 corresponds with 1, since 2 divided by 2 is 1, and so on and so forth. So that is from us dividing the number line by 2. And then it says now we flip it. So we'll take a copy of this number line, and we're going to flip it. Just like so. So now it's asking, are these the same two outcomes? For this one, we flipped it first, right? And then we divided it by 2. Whereas for this one, we divided it by 2 and then applied the negative, hence flipping it. Well, we see that, yes, it does give us the exact same outcome. And we can even check with a couple numbers. So, for example, if I take the number 4, we'll see that in this case, 4, it lines up with -2. Because what we did is we see that this is going to be dividing the 4 by 2, right? 4 corresponds with 2 because we divided this number line by 2. And then we're applying the negative to it, right? So 4 divided by 2 is 2, and then applying the negative, we get to -2, right? Whereas in this case down here, if we start at the 4, and we apply the negative to the 4 first, which gives us this, and then we divide it by 2, right, because this number line was the dividing by 2 one, we also still get negative 2. So we see that in both cases, the 4 corresponds with the same point. And that's true for any point because this number line and that number line are in the exact same position. So we see that for part A, it doesn't matter the order in which we did those two operations. Let's look at part B and see if it's the same. So I flipped the number line and then added 2. Will this produce the same outcome as if I added 2 first and then flipped it? All right, so I have a number line here. And it says we flip it and then add 2. Okay, so we have our number line and we are flipping it. Right, so positives correspond with negatives, negatives correspond with positives, just as applying a negative does. And then we're going to be adding 2. So let's take a copy of this number line here, right? Exact same as the one above, and we're adding 2 to it. Now, you might think, oh, adding 2, let's slide it to the right by 2. But what does addition by 2 do? It moves the number line in the positive direction. But here, the positive direction has been flipped, right? The positive direction is this way. So when we add 2 to the number line, we're actually going to be sliding it 2 in this direction. And we see that should make sense since 0 lines up with 2, 1 lines up with 3, 2 lines up with 4, everything lines up with itself plus 2. So it still makes sense in that regard. All right, so that is the result of us flipping the number line and then adding 2 to it. All right, so now let's take the number line. We're going to add 2 to it and then flip it and see if it gives us the same result. So I'm going to have to borrow this here. So adding 2, we go 1, 2, right? So 2 lines up with 4, 7 lines up with 9, everything lines up with itself plus 2. And then we're going to flip it. So to borrow this one, we take this and we flip it. So does this result here, where we added 2 and then flipped it, is that the same thing as when we flipped it and then added 2? No, we see that they are in actually different positions, right? And the reason for this is that here we've flipped the number line and then added 2. But this addition of 2 is actually going in a different direction now because we flipped it. And in the second case, we added 2 first and then flipped it. So we went in a different direction when we did this addition. So these do not produce the same thing. Whereas in this case, we're not sliding anything. All we're doing is we're just stretching the numbers. And so that has nothing to do with direction. And so flipping it and then dividing it by 2 will be the exact same thing as if we just compressed it first and then flipped it because we aren't actually sliding it anywhere. So I hope part 4 made sense to you, and feel free to try this with several other combinations, like what if I multiplied by 3 and then added 1 versus added 1 and then multiplied by 3? Is that the same thing? So try some combinations and find out what you get. Alright, well, I hope you found that video interesting. Thanks for watching. Have a good one, stay groovy, and I'll see you in the next video.